Hi, today I'm going to talk about our work on AI-powered code assistants for notebooks. Applications of AI to coding tools, and just tools in general, are becoming increasingly prominent and useful. They have found their way into a wide variety of environments and contexts, ranging from the widely discussed ChatGPT to image generation models like Midjourney, and even into Excel. These assistants often exist within IDEs and respond to users' code with suggestions. For instance, this demo from Copilot automatically creates a sentiment analysis code based on a natural language comment and a type signature. Being situated in a particular context allows the system to adapt to the particularities of a given domain. Beyond IDEs, there have been ample successes integrating AI into a variety of other tools, again, such as spreadsheets. But little is known about how they might be effectively integrated into notebooks. So why can't we just throw Copilot at notebooks and call it a day? Well, tools like Copilot are primarily designed for IDEs, which have some critical differences from the expected usage of notebooks. IDEs are typically just focused on code, whereas notebooks are multimodal, incorporating graphics, code, markdown, and other formats. IDEs often aim to produce clean, production-level code, whereas code in notebooks is often exploratory or messy. And finally, and maybe most notably, they have disjoint and cadences. In IDEs, you run the whole program, whereas notebooks provide incremental, piecewise execution through cells. It would seem then that the design of assistants for notebooks should be adapted to these differing precepts. So, to better understand how such tools might be designed, we set out to answer two questions. First, what are the available design choices for AI-powered code assistants in notebooks? And second, what do users expect from code assistants in this type of context? We address the first of these questions through a design space analysis, and the second through a design probe interview with practicing data scientists. To begin, let's look at our design space, the formation of which begins with a survey. To get a better understanding of this type of tool, in terms of what features they have, how users interact with them, and so on, we conducted a small survey of assistant-style systems. In assembling the survey, we sought to build a maximum variation sample such that we might understand the boundaries of this space, rather than characterize popular patterns, which will no doubt change as technologies evolve. We've already seen Copilot, so let's look at a couple of dissimilar systems from our survey. Consider, for instance, Mito. This tool allows users to specify programmatic modifications to pandas data frames by using a spreadsheet-like interface, wherein edits are synthesized via a heuristically tuned program synthesis model that, notably, can only unidirectionally create code. In contrast, consider the tool B2 from Wu and Friends, which allows users to make bidirectional moves that go back and forth between a graphical representation and a textual representation, a visual analytics style suite of charts on the right, and the notebook code on the left, respectively. Notably, it does so in a manner that preserves interaction with history as code. All told, we identified 14 quite different systems that approach the problem of generating code in notebooks in different ways and for different reasons. From this sample, we built up a design space for code assistants in notebooks, the key top-level partition of which is between how the user interacts with the assistant and the way in which the assistant's interface is manifested. In addition to properties that we observed in our survey, this framing allowed us to identify a number of novel design elements. Now, time is short today, so let's just look deeply at one of these topics, namely code context, which we'll illustrate via some mockups. We find that there are 4 places within the interface that such assistants might exist, the first of which is ambiently, or throughout the interface, such as exemplified by Copilot-style interfaces in which suggestions are provided as autocompletes. Assistants can also focus on a single targeted cell. Such assistants might take the form of cell wizards or just other dedicated interfaces that are contextualized to a given cell, such as here in this mockup. Next is between cells, or what we refer to as inline cells. Such assistants might act as a new type of cell that generates code cells, much in the same way that a code cell generates output cells. We saw such an interface briefly with Mito, but in this mockup we see an assistant generating a code cell based on a natural language prompt. Finally, assistants can be formed at an application level. That is, those assistants that exist out of the flow of the notebook and whose scope is implicitly set to contain the entire notebook. For instance, B2 works in this fashion, and as does this interaction shown in this mockup. These 4 places in the notebook in which assistants might operate also allow the user to implicitly describe their intended context or scope. Something can be context-free, such as maybe documentation lookup. It can be on a document or on an application level, whereas something contextual, like an explain my code button, should likely happen locally, such as on a targeted cell level. Across the rest of the design space, we apply similar analyses and breakdowns for each component of the interface and interaction that we identify, and therein are able to generally characterize the design space of possible assistants. Now that we know what shapes these assistants might take, let's consider our next question and study what users expect from them. To answer this question, we conducted a design probe with 15 practicing data scientists who had prior experience using code assistants, such as Copilot. Through this study, we sought to elicit their opinions, expectations, and beliefs about notebook assistants. In particular, we sought their opinions on code context, disambiguation, adaptation, and code provenance, or history. For each of these topics, we created a suite of designs and then asked participants to imagine they were addressing some common data science tasks, such as visualization or wrangling, and to consider how these designs might affect their approach to such tasks. For example, in the disambiguation section, we considered a series of designs that explored different ways to represent alternatives. These designs involve a number of different strategies, including showing just the output of the suggestion, diffs between code suggestions, and higher-level summaries, such as clusters of suggestion types. The particularities of these designs are interesting, but our conversation with the data scientists used these and other designs as a jumping-off point to talk about more complicated topics and ideas. So, what did we find in those conversations? Well, in short, we found a lot of interesting things. These ranged across patterns related to politeness, or how the system respects the user's agency, patterns related to notebook-based assistants, as well as some findings about just code assistants more generally. But for today, I just want to highlight a handful of these. The first of which is that code assistants should be designed so that they are treated like ghostwriters. Respondents observed that their perceived contribution governed what types of tasks that they would trust the assistant to perform. For instance, one participant noted that they wouldn't trust the system to build an ML pipeline, which he viewed as the core part of his job, but would trust it to make charts for him, as he did not view that as an essential part of his work. Another participant, whose primary work involved producing analyses, felt that he would not trust the system to build charts for him. So what things should we try to automate in this context? Well, it depends on how the users view themselves and the nature of their work. Next, we found that different users wanted different things from the interface, or even just different interfaces altogether. Data scientists, of course, are a heterogeneous user type with diverse tasks, so no one presentation of information or assistant form will be perfect for everyone, nor for every type of approach, or even for a single user across all tasks. To wit, some participants valued the locality of things like the targeted cell form we saw earlier, while others liked the ergonomics offered by an application-style design with widescreens. In addition, several participants noted that they would likely use such designs for different tasks. For instance, the application form might be well matched to explore alternatives before integrating them into the notebook, compared to something like the inline design. We suggest that having multiple ways of interacting with an assistant is more useful than a general-purpose assistant that acts only in a single fashion, as this allows their advice to be localized to a given task. And finally, something that came up across a number of interviews was that something like a linter or high-level spell checker might be valuable. Having an assistant that doesn't just help with code, but also helps maintain notebook and data science best practices, such as avoiding out-of-order executions and so on, in a non-domineering way, was seen as valuable and a useful way to surface domain knowledge. Further, participants, such as P5, noted that they tend to be pretty messy in notebooks, and that a tool like a linter might help them more effectively follow best practices. Finally, it was suggested that such a tool need be backed by AI, as something static or predictable might be better able to impart new concepts. The question of user expectation for this type of rapidly evolving tool is complicated, and there are lots more answers from our studies in the paper. But in closing, I'll leave you with this. Integration of code assistants backed by AIs offers rich potential to radically improve notebook users' programming experience and efficacy. Through our characterization of the design space and elicitation of realistic user expectations and opinions, we hope to empower future designers to build more helpful code assistants. The key takeaway designers of such systems should have then is this: to be effective, notebook assistants must be respectful of their users and usage domain.